Okay, before we start talking about logarithms, I need to talk about exponential functions. Exponential functions are typically in the form of a times b to the power of x. With logarithms, we're really going to be working where a is 1, so it's just b to the power of x. You might say, well, we've seen things like that before, and you have. The big difference is that exponent is going to be a variable always. With exponential functions, that's why it has the name exponential functions, because the exponent is the variable. Here's the graph of exponential functions. This is the graph of a logarithm. Now, logarithms are inverses of exponential functions. As you can see, kind of from the exponential function graph, how it looks like it's reflected over that y equals x line, which we learned last chapter, how inverses are a reflection of the y equals x line of the original function. So we're going to be working with logarithms in this lesson. All right, so here's a big comparison. Logarithms, well, typically exponential form is b to the power of x equals y. That's exponential form. So the logarithmic form of that function would be log base by equals x. What we're going to be doing here is we're going to be using these two forms interchangeably. We're going to be writing logarithmic forms as exponential forms and then vice versa. But then we're also going to use both forms to evaluate logarithms. Okay, so writing in logarithmic form. So if we have an exponential form like 2 to the third power equals 8, it can be, so our b is 2, our x is 3, and our y is 8. It can be rewritten as log base 2 of 8 equals 3. Another example, if we have 4 squared equals 16, that can be rewritten as log base 4, 16 equals 2. And again, because 4 to the second power equals 16 and 2 to the third power equals 8. That's why it can be written from the exponential form to that logarithmic form. Like I said, the other thing we're going to have to do is evaluate logarithms. So in this case, we're asked to evaluate log base 9 of 27. Basically, it's saying log base 9 of 27 equals what? There's actually a couple different ways you can evaluate it. Right now, I'm going to show you how to convert it to exponential form to evaluate it. So our base is 9, our x is unknown, because that's what the logarithm equals, and our y is 27. So we could rewrite this as 9 to the power of x equals 27. And we know that 9 to what power equals 27? Well, 9 to the first power is 9, 9 to the second is 81, so it has to be somewhere in between the two. So we could just work with it and get. So I started in, let's say, 1.5. So 9 to the 1.5 power is 27. And then I could work from there. So evaluate log of 100. Now, it could be a little confusing because you might say, well, where's the base? You have to know, and if you don't have this ready to write down yet, write it down, that when you have a logarithm, when the base is not written, you have to know and assume that it's 10. The common base of a logarithm is 10. So in this case, log 100, it's actually log base 10 of 100. And so we need to ask ourselves 10 to what power equals 100? And since 10 to the second power is 100, x equals 2. So the solution to that second evaluate the logarithm is 2, and the solution to the first evaluate the logarithm is 1.5 or 3/2. Now the nice thing, if you ever see anything in the form of evaluate log 100, your calculators are programmed to have the common base or common logarithm of 10. So you could really just type log 100 in your calculator. Now the one where the base is 9 or any other base, there is a way in the graphing calculators you can adjust the base, but I'll let